All right, let's dive straight in. What we're exploring here is Rogerio Lorenzo's framework, which puts forward a pretty radical reframing of what numerals are. The core idea? To stop seeing them as abstract objects and start treating them as what they really are, a sophisticated cognitive technology. And it all kicks off from this single epistemological principle. Lorenzo's point is that measurement isn't an act of discovery. It's not like we're just finding some pre-existing reality. No, it's an act of mediation, it's relational. And this simple, powerful idea is really the foundation for everything that follows. So, how do we build the case? Well, we start with a very basic, empirical observation about language itself. And right away, this uncovers a deep paradox, something strange right at the heart of what a numeral even is. To get a handle on this, Lorenzo gives us the phonological discursive matrix. Think of it as a model for understanding this fundamental tension, a tension between how a numeral sounds and how it actually works in the real world. And this is where it gets really interesting. Let's take the word three. Phonologically, it sounds complete, right? It feels like a finished, self-contained thing. Lorenzo calls this a phonological trap because it tricks us into thinking it's autonomous. But discursively, well, it's totally incomplete. It's always asking the question, three of what? It needs a host. So we have this paradox. How is it resolved? It turns out there's an underlying grammatical structure that makes it all work, an invisible mechanism that explains this dependency. The question is, what is it? The key concept here is the null position, or N0. Now, this isn't something physical. You can't see it. It's an invisible structural requirement, an empty slot hardwired into our cognitive grammar. And every single numeral, to make any sense, has to anchor itself to this slot. And we can prove this really easily. Let's run a quick autonomy test. If I just say I have three, what happens? The whole thing is pragmatically broken. You immediately have to ask three what? The numeral 3 is meaningless until something, an instance, S, fills that invisible null position. You can see its supposed autonomy just completely collapses under the slightest bit of pressure. So this begs a massive question, doesn't it? If numerals are so clearly dependent on this invisible grammar, why on earth do they feel so independent, so autonomous? How does this powerful cognitive illusion give rise to something as huge as mathematical Platonism? Well, Lorenzo argues that it's a three-step cognitive slip-up, what he calls the triple conflation. First, we notice modal inevitability. We all agree, within our counting system, 3 has to follow 2. That's just a structural fact. But then we slide from that into a feeling of temporal latency, this sense that the number was somehow latent or waiting for us to count it. And from there, it's a short leap to ontological preexistence, the idea that the number was already out there in some Platonic realm before we ever started counting. And this right here is the heart of the Platonist error. We're taking a property that comes after the fact, the inevitability within a stable, human-made system, and we're confusing it for a metaphysical status that existed before the fact. We're mistaking a property of the system for a property of the world. Okay, this all leads us to a framework that Stephen directly engages with your work on cognitive technologies. What it offers is a powerful way to finally unify the micro-level grammar we've been talking about with those macro-level cultural and material systems that you've analyzed so brilliantly. Now, to really make that connection, the framework intentionally retires the old parasitic metaphor from linguistics. Instead, it proposes a much more precise concept, tool dependency. The idea here is that this dependency isn't a flaw. It's the absolute defining feature of any and all cognitive tools. From this vantage point, the alphanumeric image is the cognitive technology. Its function is nothing more than a system effect. It only emerges from the context it's embedded in. And what's so powerful about this is that it provides a specific, micro-level grammatical mechanism, that null position, for the large-scale cognitive effects of cultural and notational variation that you've documented so well. So this tool dependency, it's not some monolithic thing. It actually operates on 3 different nested layers. And for any mathematical act to even happen, it has to be activated across all 3 of these layers at once. So what are they? You've got the syntactic layer, the natural language that frames everything, like let n be. Then you've got the inscription layer, the actual system of notation we're using, whether it's Hindu or Arabic or Roman. And finally, there's the schematic visual layer, the diagrams, the spatial arrangement, the whole visual context of the page. This incredibly deep, multi-layered dependency makes numerals a real headache for classical linguistic typologies, especially for a system like Haskell Maths, which really relies on having clean, distinct categories. Numerals just don't fit. So let's break that down. In Haskell Maths typology, you've got affixes, which are highly selective. They only attach to certain word classes. Then you have clitics, which are non-selective. Well, where do numerals fit? They're a hybrid. They're phonologically free, like a standalone word, but they're discursively bound, like a root that can't exist on its own. To capture this weird hybrid status, Lorenzo proposes a new category, the bound root. So this brings us to the final, and I think most radical synthesis of the entire framework. It's a proposal to reunify two cognitive faculties, reading and counting, that, let's be honest, our fields have spent a very long time treating as completely separate things. The argument, quite simply, is that the whole reading versus counting debate is built on a false dichotomy. The goal shouldn't be to try and build a bridge between them. The goal is to recognize that, at the most fundamental level, they were never separate to begin with. They're just two poles of a single cognitive operation, an operation on what Lorenzo calls the alphanumeric image. Reading is what happens when we foreground the verbal aspect. Counting is what happens when we foreground the numerical. But both are working on the exact same unified cognitive substrate. And we even have linguistic fossils that point to this, like the Portuguese verb contar, which fascinatingly means both to count and to tell a story. And that leaves us with a pretty provocative question. This framework offers more than just a new way to look at math. It offers a potential methodology. If reading and counting share an invisible grammar, it makes you wonder, what other hidden multi-layered dependencies, what other invisible grammars might be underpinning all the other cognitive technologies that you and so many others have so brilliantly explored across human history?